Hi YouTube, this is Further Pure 3 2006, question 1, induction, a to the power n as this matrix for all positive integers. So substituting n equals 1 is true, assuming true for n equals k, considering n equals k plus 1, a to the power k plus 1 will be a to the power k times a. So applying, we see that k plus 1 is satisfied here, but considering the top right starred expression, simplifying further to here, considering the proof required for induction, adjusting and simplifying further, then it is true for n equals k plus 1, then by induction true for all n from the positive integers. Question 2, a Taylor series of cos 2x in ascending powers of x minus pi over 4 up to the term in x minus pi over 4 5 to the power 5, and in part B an estimate of cos 2. So differentiating to 5 and substituting pi over 4 and adjusting Maclaren's theorem for x minus pi over 4 and substituting the results gives the series required. So for an estimate of cos 2, then x will be 1, and using our result from A evaluates to minus 0.416147. The Taylor series and the estimate. Question 3, De Moivre's theorem to prove sin 5 theta is this expression in A, and to solve the equation in B. For part A, De Moivre's theorem states cos 5 theta plus I sin 5 theta is cos theta plus I sin theta to the power 5. So applying the binomial expansion and simplifying, and then equating the imaginary parts for sin 5 theta and substituting some identities and simplifying gives the proof required. So for part B, using our result from A and expressing cos theta sin 2 theta as 2 cos squared theta sin theta and adjusting the factorization, we can see that theta equals 0 is one solution. Factorizing the quadratic gives 4 more solutions. Cos theta is plus or minus 1 over root 8 and plus or minus 1 over root 2. So 4 more solutions for theta. The binomial expansion equating for sin 5 theta and the 5 solutions. So the solutions on the sketch here, including 0, and pi is not included. Question 4, approximations of the form given in A for t equals 0.1, 0.2 and 0.3. A series solution to t cubed in B, and an estimate of x at t equals 0.3 in C. So using the forms given dx dt is 0.4, x equals 0 at t equals 0. The first approximation will be 0.4 approximate to x.1 minus 0 over 0.1, which gives x.1 as 0.04. And then considering the next approximation for t equals 0.2, evaluating for d squared x dt squared 0.1, and then using this for the form required, evaluating for x.2, and then for the approximation for t equals 0.3, evaluating d squared x dt squared 0.2, and using this to evaluate using the form required for x.3, giving 0.11534. So for a series solution, differentiating to 3 and substituting 0 and then applying the Maclaurin theorem gives the series required. And for an estimate of t at 0.3, substituting in our series in B gives an approximation of 0.1146. So for our series in B and an estimate of t equals 0.3 in C. Question 5. Eigenvectors. To find the two eigenvalues in A of the matrix M. Find the inverse of M in B, and to verify that the eigenvalues of the inverse are the inverse of the two values found in A. Then a transformation T, two lines are mapped onto themselves under T to find Cartesian equations for each of these lines. So for part A, solving determinant m minus lambda I equals 0, simplifies and factorizes to give two eigenvalues of 2 and 3. And then for the inverse, will be given by this expression. So we can write down the inverse as 1 over 6, 1, 2 minus 1, 4. And then solving determinant m minus 1 minus lambda I equals 0. And simplifying and factorizing proves that the two eigenvalues are the inverse of those found in A. So for a Cartesian equation, considering the transformation T maps the lines onto themselves, then we can use the eigenvectors. So applying using lambda equals 2 gives y equals x, and applying lambda equals 3 gives y equals a half x, given the Cartesian equations required. So the two eigenvalues in A, the inverse of M, the eigenvalues of the inverse, the eigenvectors of M, showing y equals x and y equals a half x. Thank you for watching. I'll start question 6. in the next video.